Defer is a small keyword with an outsized effect on how Go code reads. It schedules a function call to run when the surrounding function is about to return. And the important part is, no matter how it returns, early, late, from the middle of a loop, or because something went wrong, it is the single feature that makes Go's resource handling feel tidy, and it takes about 5 minutes to learn. Here is the whole idea in 3 lines. The word defer in front of a call means, do not run this now. Run it when this function is about to finish. So even though the world line is written first, it does not go first. Hello prints first, because it is the first line that actually runs. Then main reaches its end, and the deferred call fires. The call was scheduled on the defer line and executed at the very end. That gap between scheduling and running is the entire feature. This is what defer is really for. In real code, you open something that has to be closed again. A file, a network connection, a lock on some shared data. The old way is to remember to close it at the end, and on every early return in between, and in the error path, and in the one somebody adds next year. With defer, you write the close immediately, 1 line after the open, before you have written any of the code in between. Now it runs on every single return below it, including ones that do not exist yet. Look at what that does to the reading experience. The open and the close are 1 line apart, so you can see at a glance that the resource is handled. In a language without defer, those 2 lines can be 100 lines apart, and the only way to check is to trace every exit path by hand. You can defer as many calls as you like, and they run in reverse order. Last one deferred is the first one to run. Think of stacking plates. The last plate you put on the pile is the first one you take off. So this prints start, then end, and then 3, 2, 1. Start and end print in the order written. Because they are ordinary calls, the 3 deferred ones stack up and unwind backwards. And reverse order is exactly what you want for cleanup. If you opened a file and then took a lock, you want to release the lock first and close the file second. You tear down in the opposite order you set up. Defer gives you that for free, without you having to think about it. Now, a subtle detail that matters, and it is the one thing about defer people get wrong. The call runs later, but its arguments are worked out immediately, at the moment you write defer. So X is 1 when we hit the defer line, and that one is captured right there and then. Afterwards, we change X to 99, and the ordinary print shows 99, as you would expect. But the deferred line prints 1, not 99. The value was frozen when the defer was scheduled. Say it to yourself as, the call is late, the arguments are early. If you genuinely need the deferred call to see the final value, you defer a small function instead of a call, and read X inside it. That is a closure, and we will cover it properly in the Functions module. One important warning about this specific example. This is the one place in the whole course where the in-browser interpreter disagrees with RealGo. The interpreter works the arguments out late and prints 99. Compiled Go freezes them at the defer line and prints 1, exactly as I have described. So on this one point, trust the explanation rather than an experiment in the lesson box. On your own machine, Go Run gives you one. Here is the shape you will write over and over again in RealGo. Acquire the thing, immediately defer releasing it, then get on with the work in between. Notice the closing line is written second, but it happens last, after the working line. Call process with the word database, and you get opening database, working with database, closing database, in that order. Call it again with cache, and the whole cycle repeats cleanly, because the defer belongs to each individual call of the function, not to the program. That is worth being clear about. Defer is tied to the function it is written in. When that function returns, its deferred calls run, not at the end of the program. 3 things, and if you remember them, you understand defer completely. The call is late. It happens at the end of the function. The arguments are early. They are captured the moment you write defer. And it runs however the function returns: normal return, early return, or a panic on its way out. That last one is what makes defer trustworthy, rather than merely convenient. 4 things to carry away. Defer schedules a call for when the surrounding function returns, whatever route it takes to get there. Write the cleanup one line after the setup. Then it is impossible to forget, and obvious to whoever reads it next. Several defers unwind in reverse order, which is exactly the order you want for tearing things down. And the arguments are worked out at the defer line, not later. That is the whole feature. Small, and it changes how the rest of the language feels. Your turn. Make a program print task started, then task finished, then cleaning up. The catch is that the cleaning up line has to be written at the top of main, using a single defer, so that it runs last automatically. Pause and try it. Here is the answer, and it is one word of difference from a program that prints them in the wrong order. Cleaning up is written first and runs last. The 2 ordinary prints run in the order they appear. Take the word defer away, and the output reverses into the order you actually wrote. That one word is doing all the work, and that wraps up control flow entirely. You can branch with if and switch, loop with for in its 4 shapes, and guarantee cleanup with defer. That is the backbone of every program you will ever write. Next module, functions. This is where Go's real character starts to show, with multiple return values and errors returned rather than thrown.